What if I told you that the sound of your own voice could hold the key to understanding the health of your brain? I know, it sounds a little like science fiction, right? But some really cutting edge research suggests our speech patterns contain these hidden clues about our cognitive and mental well being. So let's dive into how this incredible technology actually works. Right now, figuring out what's going on with our brain health is, well, it's really tough. When you think about diagnosing conditions like depression or trying to catch the very early signs of dementia, it often comes down to subjective things like how a patient says they feel. Or it involves expensive brain scans or pretty invasive procedures like spinal taps. The problem is, these methods aren't always easy to get, and a lot of the time, they only spot the problem after significant changes have already happened.
So, this all raises a really fascinating question. What if we could find a way to monitor brain health that's non invasive, totally accessible, and objective? What if we could do it just by listening to someone speak? Think about it. The act of speaking is just incredibly complex. It's this amazing coordination of all these different cognitive and motor processes in your brain. And because of that, even tiny, almost imperceptible changes in your voice can give us a really sensitive snapshot of your underlying cognitive function. It's like a window into your brain's operations. And that brings us to the core idea of this whole field, something called vocal biomarkers. Scientists are learning how to decode these signals to get a much clearer picture of what's happening inside our minds. So, what exactly is a vocal biomarker? Well, think of it as a measurable feature of your voice, things like your pitch, your speed, or your tone that can signal a change in your health. It's basically a clue captured right there in your speech that reflects your internal state without needing any invasive tests at all. And these clues, they basically fall into two big buckets. First, you've got acoustic features. This is all about how you speak. We're talking about pitch, volume, and even these tiny, tiny variations in frequency and amplitude called jitter and shimmer that you can't even consciously hear. The cool thing is, this stuff is language independent. Then you have the linguistic features, and this is about what you say. Here we're analyzing things like your vocabulary choice or how complex your sentences are, which, of course, is language dependent. Okay, so that's the theory. But how does this all translate into actual diagnoses? Let's take a look at how researchers are building this bridge between someone's voice and specific health conditions. I mean, just look at this. The patterns researchers have found are pretty consistent and really compelling. For instance, we see that major depression often lines up with a flatter, more monotone pitch. High stress, that can lead to a higher pitch and more breathiness in your voice. And when it comes to neurodegenerative conditions like Parkinson's or Alzheimer's, we start to see clear changes in things like articulation, speech rate, and how often someone pauses. And get this, here's a statistic that really drives home the potential here. Nearly 90% of people with Parkinson's disease experience some form of speech disorder. Why? Because Parkinson's impacts a part of the brain called the basal ganglia, which is crucial for motor control, including all those fine muscle movements we need for clear speech. And these vocal changes can often be picked up 5 years, sometimes even more, before a clinical diagnosis is made. That opens up a huge window for early intervention. Now, this finding is truly remarkable. A huge study on major depressive disorder, or MDD, found something fascinating. They saw that people who had a genetic risk for depression, but who weren't actually showing any symptoms at the time, already had some of the same vocal markers. Think about that for a second. It suggests your voice might not only reflect how you feel now, but it could also hint at a future vulnerability. So we've seen just how powerful speech analysis can be. But what if there's an even more sensitive, and maybe even a more engaging way to capture these vocal clues? What about singing? Let's break down why singing might actually be a better tool here. For some patients, especially those with cognitive issues, just doing a speech task can be difficult or frustrating. Singing, on the other hand, is often just more engaging and fun. Plus, neuroimaging shows that it actually activates unique neural pathways, different from the ones used for speech. And because singing demands more complex vocal control and can be easily standardized across cultures with familiar songs, it might just be a more sensitive tool for spotting those really subtle neurological changes. And here's the beautiful part. The power of singing doesn't stop at diagnosis. Music therapy, and especially singing, is already a well-established clinical practice. It's used to help improve memory, mood, and cognitive function in patients with dementia, Parkinson's, and even those recovering from strokes. So it's this amazing two-for-one. It can be a way to measure health and a way to improve it. Okay, this all sounds incredibly promising, doesn't it? But what's it actually going to take to get this technology out of the research lab and into your doctor's office? Well, there are some pretty significant hurdles we have to clear. First, data privacy is a huge deal. Your voice is a biometric identifier, just like your fingerprint, so we have to keep that data incredibly safe. The AI models also have to be unbelievably accurate across different languages, accents, and even the kind of microphone someone is using. And we have to think really carefully about error margins. A model that's 70% accurate is still wrong 30% of the time, and a false diagnosis can cause real harm.
So, for this technology to become a trusted medical tool, it has to pass this really rigorous three-step validation process. First up is verification. Does the tech even capture the audio correctly? Simple, but crucial. Second is analytical validation. Does the feature reliably measure what it claims to measure? And finally, the most important step, clinical validation. This is where you have to prove that this tool provides real, actionable value that helps doctors diagnose and care for their patients. So this all brings us to a final, pretty provocative thought. As this technology gets better and we overcome these challenges, it's entirely possible that your future health assessment won't start with a questionnaire or a blood test, but with a simple request to speak a few sentences, or maybe, just maybe, to sing a song.